Lesson 7.4, Equations in Quadratic Form. The objective here is going to be to recognize and solve equations that are in quadratic form, although they may not necessarily appear that way at first. So what we're going to see here, for example, if we look at these three equations to look for similarities and show how they actually do seem to be quadratic in nature, well, the first one is definitely a quadratic equation, right? This can be factored easily. This can be factored into x plus 5, x minus 2. But here it seems like at first this is not a quadratic. But if you look at it, this x, well, that's really this term right here. And I'll underline it. That's like x squared plus 3x minus 10. This is the same thing. This is like x squared plus 3x minus 10. So what I've circled and underlined there in red is like as if there's an x there. And what we're going to see is we're going to use the idea of calling it some random variables, let's say u, solving for that value of u, and then setting that answer equal to the expression that was defined as u. So what we'll notice is really is this. This is like f of x squared plus 3 times f of x minus 10 equals 0. And traditionally, the value we set equal to u ends up being the middle term for the most part. Okay, the variable portion of the middle term, which we're calling f of x. So example 1 we have here, we're going to see it's a clear example of what we just said. So for this example, we could start by saying, let u equal 2x plus 1. And that leads us to the fact that, well, u squared is simply 2x plus 1 squared. So this equation then reduces to u squared minus 4 times u equals 21. We can move the 21 over, and we have a quadratic equation. Let's go ahead and factor this to solve. This can easily be factored into u minus 7 and u plus 3. Giving us two solutions for u, negative 3 and positive 7. But we're clearly not done because this problem is asking us to solve this equation, which has x in it. So we take the answer we got for u, or the two answers, and we set them equal separately to the expression that was defined as u. So again, let's take this negative 3 here. And again, negative 3 is equal to u, but u is equal to 2x plus 1. So negative 3 has to equal 2x plus 1. And then 7 has to equal 2x plus 1. So those are the two cases we have now for our almost like an expanded t-chart in a sense. Let's go ahead and solve these equations separately. Moving the 1 over, we get negative 4 equals 2x, or x equals negative 2. Moving the 1 over, we get 6 equals 2x, or simply x equals 3. So our answers for x are 3 or negative 2. In example 2, we're going to see we have the quantity 2x minus 7 radical x plus 6 equals 0. And we can solve this. We can solve this thinking of this as a linear radical equation, or we can think of the fact that the middle term squared becomes this first term here. So we can start by letting u equal radical x. But we have to remember for these questions that we have to check our answer for all of these. So we have to make sure that we go ahead and check the solution for these. So we're going to see that we get that u squared is equal to just x, right? If we square both sides of that. So if I replace x with u squared, I get 2u squared minus 7u plus 6 equals 0. Then I can go ahead and solve for u by factoring this. This is, again, easily factorable. This one is 2u minus 3 and u minus 2. Solving here, we're going to get u equals 3 halves and u equals 2, or u equals 2. So those are the possible solutions for u. And since u is defined as radical x from up here, we can go ahead and set this 3 halves equal to radical x, and set this value of 2 equal to radical x. Again, those are our definitions of u. How to get rid of a radical? Let's square both sides. We're going to get x equals 9 over 4, or x equals 4. Now when we check both answers here, we'll see that both of them work, giving us a solution set of 4 or 9/4. Example 3 says to solve the quantity 3 over x squared plus the quantity 6 over x minus 35 equals 0. Now, at first it looks like, well, there's a problem here because the middle term is 6 over x, but the first term is not 6 over x squared. Well, I mean, it's not really that big a deal. All we can do is start by doing this, right? Write it as 3 over x still. But then here, let's take out simply a 2 out in front. And then we can write this as 3 over x, and then minus 35. And that's mathematically sound because I can just multiply out, right? Remember that this 2 multiplied by the top, making that 6. So now we'll call this u, and then therefore we have u squared being the quantity 3 over x squared, which is the first term. So this gives us an equation of u squared plus 2, so don't forget this 2 here, u minus 35 equals 0. This gives me factors of u plus 7 and u minus 5, giving me answers for u of negative 7 or 5. Well, again, that's what u is, but u is defined as 3 over x, so let's set each of those equal to 3 over x. So 3 over x equals this negative 7, or 3 over x equals this 5. Solving these, remember, multiply both sides by x to make this 3 equals negative 7x, and this side 3 equals 5x, and then divide by the coefficient. So this is going to be 3 over negative 7, that's the first x value, and 3 over 5 is the second x value. Remember, you can quickly just switch these two positions when you're solving for a simple variable that's in a denominator. And our solution set is simply 3/5 or negative 3/7. Example 4 says to solve x to the 4th plus x squared equals 12. Well, let's start by moving the 12 over right away, giving us x to the 4th plus x squared minus 12 equals 0. And we did a problem like this earlier in the year where we end up factoring it to x squared plus some number and x squared minus some number. Well, we could do that, and that works still. Or we could start by saying let u equal the middle term, right? Let u equal x squared, and thus u squared is equal to x to the 4th. And we could replace those. So that's really where this technique early in the year comes from. This equation becomes u squared, because that goes in for x to the 4th. And this u goes in for x squared here. So u squared plus u minus 12 equals 0. Well, this becomes u plus 4 and u minus 3 equals 0. Solving these, we get u equals negative 4 and u equals positive 3. Well, u is defined as x squared back up here at the top, so we can say that x squared equals negative 4 and x squared equals 3. Well, let's take a look at this now. What happens is this. We end up getting a square root of a negative number here, giving us an imaginary answer. So x is equal to plus or minus. Now remember, this is square root of negative 4. But the square root of negative 4, if you remember, is just going to be an I out in front and then a radical 4. But radical 4 is 2, so plus or minus 2i. And on the right-hand side, we take the square root of both sides, getting us x equals plus or minus radical 3. So how many answers do we get in the end? We get 4 answers. Plus or minus 2i and plus or minus radical 3. Had you done this problem initially by looking at it the way we had earlier in the year and written it this way, as factoring into x squared plus 4, x squared minus 3 equals 0, you get the same answer, because you'd have to solve this one giving you plus or minus 2i, and solve this one set equal to 0 giving you plus or minus radical 3. Example 5 says 3 times the quantity 2x minus 3 squared plus 10 minus 19 equals 0. Well, here clearly have to do some work. Okay, we have to do some work. We have to think about it this way. Well, first of all, the first term, this 2x minus 3, we're not going to want to mess around with this at all. So we kind of want to get a 2x minus 3 in the middle here. But it doesn't look like we have that. But what I can do is think about it this way. What if I break up this 19? If I break that into maybe 15 and 4, let's see what it looks like. Now that hasn't changed the value at all because it's still minus 19, but what we'll notice is this. The reason I broke it into 15 and 4 is because 15 happens to be a multiple of 5, and so is 10, so I could factor out a 5 here. If I factor out a 5, I'll leave this to be 2x, and I'll make this a minus 3, giving me 2x minus 3. So on the next line, I'm going to write it like this. Okay, so it's kind of like the idea, and it's not completing the square, but it's like the idea that we make the equation what we want it to be, even though it hasn't changed the value anywhere. So this becomes letting 2x minus 3 equal u, and thus u squared is equal to 2x minus 3 quantity squared. Okay, letting that statement be true, we get the following. 3u squared plus 5u minus 4 equals 0. Again, 3u squared plus 5u minus 4. And now we have to factor this, which can be a little bit messy, so we could factor this by AC method, but we'll notice that if we try AC method, it fails. So if this fails, then we have to go ahead and figure out another way to solve this. Well, the only way to solve a quadratic that's not factorable is by using our quadratic formula. So let's go ahead and use our quadratic formula. So we say that u equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And what this reduces to is negative 5 plus or minus radical 73 all over 6. Now, with those two solutions for u, we have to then think about, all right, well, what are these values even as decimals? Because we're going to have to try and find x. Remember that u is defined as 2x minus 3, so we have to set 2x minus 3 equal to this whole quantity. Well, we're not going to want to solve that with a radical, so let's figure out the decimal approximations of u. So if I do negative 5 plus root 73 over 6, I get an approximation in this case of 0.59. And if we take a look at the other solution of u equals negative 5 minus radical 73 all over 6, right, the second answer, that's where this plus or minus sign came about from here, two answers, we'll get a decimal approximation of around negative 2.26. Well, those are the values of u. But remember again that u was defined as 2x minus 3 from the top up there. So set each of these decimals equal to 2x minus 3. Okay, we're going to solve both of these by adding 3 and then dividing by 2. This gives me, again, add 3 and divide by 2. An x value over here of 1.80. And then adding 3 over here and dividing by 2, we get an x value of 0.37. Okay, again, making my solution in this problem 0.37 and 1.80. These are approximations. These are not the exact solutions, but they can still be used to check in the original to see that the answer is actually correct. Now, the final thing to note for this problem is that you could, if you wanted to, have really just multiplied out in the beginning. And we're doing this just to exaggerate the usefulness of this technique. But if you go back to the beginning of this problem and take a look at it, it might have been just as easy to FOIL this out, right? 2x minus 3, 2x minus 3, multiply it out, distribute the 3 to all those terms, then combine all like terms and solve the quadratic by using the quadratic formula. But in the end, you end up getting the same answers. Okay? Again, you end up getting these two answers here that we see.